Hello everyone, this is KK Matics, the solution to your mathematics. Today we'll be dealing with random vectors part 3. Illustrative example here. Example 1. Two cyclists left a point P at the same time. The first cyclist covered 300 meters on the bearing of 296 degrees, and the second cyclist covered 250 meters on the bearing of 206 degrees. Now calculate correct to three significant figures. A. The distance between the two cyclists, and B. The bearing of the second cyclist from the first. Solution. It's important that whenever you're given a bearing, it's important to consider every statement or sentence given. Now, being told that what they both left a point P, so we have to consider the point P, and we told that they left at the same time. The first cyclist covered 300 meters on the bearing of 296. So they left, okay, from the point P, the first cyclist, okay, we consider the first cyclist. We're going step by step. It's very important. The first cyclist covered 300 meters on the bearing of 296. The bearing of 296 will lie on the fourth quadrant, okay. Now this is 270. So 270 plus 26 degrees gives us 296. So it's the reason why you see the 286 degrees there. Yes. Well, yes, so 26 degrees there, which is exactly the same as 0, 26 degrees, because there's a three-figure bearing, so it's important for us to write in 0, 26 degrees, but it's written here 26 degrees. And then we do the distance is 300 meters, so it's written there. And the next thing is the second cyclist covered 250 meters on the bearing of 206 degrees. So 250 meters on the bearing of 206 degrees. Now, on the bearing of 206 degrees on the P, from the point P, so 206 degrees lies in the third quadrant. So it's the reason why you see it drawn this way, okay? And we calling it point B, okay? Yeah, we call it point B, as you see there. Yes, and so in considering that 26 degrees to the distance, the degree from this is 26 degrees, okay, and 206 degrees, we subtract 206 degrees from 270 degrees. Now the reason why I'm saying so is because what the measurement starts what is what we accumulated. It starts from 0 degrees all up to what this point. It starts from 0 degrees, which is from the north all up to this line. It starts from the north at the top all up to this line. This is 90, this is 90, making it 180. And then this place, okay, 180. So 180 plus what will give us 206. Okay, so that leads us to this angle here. Okay, and so if we sum 26 degrees to the angle we get here, that will give us what 90 degrees. And the reason why you see the 90-degree sign there. Yeah, so the angle that we get here will be that's 64 degrees. Yes, that's 64 degrees, and so the angle here is 64. Okay, so 64 plus 206 is what gives us 270 degrees. That's what the line here. Okay, so the degree here is 64 degrees. Okay, just for you to know that, so that you don't get confused here. So we sum them 64 plus 26, and that's what gives us 90 degrees. So that's the reason why you see the 90-degree sign there. And yes, so from there we move on and consider. And then nothing more. We weren't given any more further information. So we're just told to calculate to three significant figures, the distance between the two cyclists. Okay, so here we can't do anything further, but what we could do is join this line to that line. We can also name it as A. Okay, here the reason why we have degrees Celsius there, we have this angle theta written there. It's mainly because we're told to find the bearing. We are told to find the bearing of the second cyclist from the first. Okay, second cyclist, which is It will define the second cycle. This is the second cyclist, okay? From the first. This is the first cyclist, okay? This is the line of the first cyclist. This is the line of the second cyclist. Okay, so you're told to find the bearing of cyclist from the first, which is this. Okay, this is this angle, which is this angle. Now the reason why we have 26 degrees is because what written there, it's mainly because what this 26 degrees is alternated to this angle there. Yes, and always keep in mind, okay, if any line that is drawn from the fourth quadrant, where it meets on the other quadrant will be the second quadrant. Okay, yeah, so it's the reason why we have this map to the second quadrant. Okay, yes, and then from there, we told to find the distance between two cyclists. So we go ahead to find that the distance between two cyclists, A and B, uh, and that equals that. Okay, this is the distance, which is the square root of. We mainly use Pythagoras theorem. Okay, because this is 90. This is a right angle triangle. Okay, so we have AB equals the square root of the square of 300 plus the square of 250, and that gives us this. And then we go on ahead. Yeah, we don't define the bearing of the second cyclist from the first. So, uh, looking at it in the way in the right angle triangle form, we then can what find here we weren't given the hypotenuse. Okay, this is the hypotenuse that we found, which is 391 meters. However, in here we are interested to find the theta, so we can use tan, okay, or use trig ratio. Here, the trig ratio that you should be familiar with, which is the SOHCAHTOA. Okay, SOHCAHTOA. Now the TOA, which is tan. Okay, tan. So we making use of tan, which is opposite of our hypotenuse. Sorry, opposite of our adjacent. Okay, TOA, OA. Okay, opposite. So the opposite is what 250, which is this one. Okay, so theta here is opposite or facing this, so that is opposite to what the 250, and adjacent is the one that lies beside it. Okay, so that's the 300 meters. So that's what you see there. And so we go on and find the tan inverse of it. I mean, that gives us our theta, which is 39.8. However, in finding your theta to be 39.8 doesn't exactly means that it doesn't mean that we found the bearing of second cyclist from the first. Okay. Now always keep in mind that when dealing with three-finger bearing, it's important to always measure it from it's always measured clockwise. That means that you measure it from the north or up to what this line here. So if we have here to be theta, which is 39.8, and there to be 26 degrees, we know that this part the first quadrant is 90 degrees, so we're going to sum them, okay, from the north or up to where the degree is. Yes, and so we do that, then we get this value. Example 2 here. Okay, in this example 2, children an aeroplane flew from town A and travels 200 kilometers at the bearing of 135 degrees to town B. It then travels 250 kilometers from town B at the bearing of 045 degrees to town C. Here we told to find A, the distance of A from C and the bearing of A from C. Solution here. Yeah, it's important to have a rough diagram of this because rough diagram that rough diagram of this helps us. It makes it easier for us. If you get it wrong, if your diagram is wrong, then it means you will get it wrong. Now, here we told that an airplane flew from town A. So this is the town A, okay? Travels 200 kilometers to the bearing of 135 degrees to town B. So 135 degrees lies in there. It lies in the second quadrant, okay? This is the first, and this is the second quadrant. So we're going to draw a line from the second quadrant to B at a distance of 200 kilometers. Yeah, so that's what you see there. And then it then travels 250 kilometers from town B at a bearing of 045 degrees. 45 degrees lies in the first quadrant, right? So we draw that. Yeah, so that's the town B. So it lies 245 degrees. So we draw a line. Okay, it said it then travels 250 kilometers from town B at the bearing of 45 degrees. Don't be mindful of this. Just don't have your mind here. The reason why this is written there, it's mainly because what? Um, if we know from this from the north to this line is 180. Okay, so 45 degrees plus 135 degrees is 180. Okay, so the reason why we have 45 degrees is mainly to help us know the value or the angle here. We know that the angle here is alternate to that, and that can fill the angle here for us and make things easier for us. And so we have 45 degrees, which is alternate to the angle here. Yes, so that being said, yeah, we can then go ahead to talk about the second point, the second statement here, which is that it then travels 250 kilometers from town B at the bearing of 045 degrees to town C. So 045 degrees lies in the first quadrant, and that would be what? This side, okay? So we draw a line, and that's 250 kilometers. Yeah, and so you see that 45 degrees plus 45 degrees gives us 90, which then turns this triangle into a right angle triangle. So therefore, we can make use of Pythagoras theorem. Yes. So we're going ahead, and we know that whenever a line is drawn from the first quadrant to another quadrant, okay, it would then lie in the third quadrant. So as you see, it lies in the third quadrant. If we were to draw a line from here, okay, from this from the fourth quadrant to another quadrant, it will lie in the second quadrant. That's how it goes. Yeah. Yes. So with this, we know that also that this is 45 degrees. It's alternate to this angle here. Yeah, and it's also accumulative. We measure it from the north up to where the line is, and then we join this line to it just to make things easier for us. Uh, just for us to have a triangle, and in joining the line to it, here we told to find the bearing of A from C, and the bearing of A from C is this angle that we need to find. Obviously, keep in mind from C is the important thing. Just when you hear the bearing of A from C, just focus on the C. Where the C is, that's where the angle we're talking about. Okay, where C is where the angle will be. So if we find this angle here, the angle here, which is theta degrees. Now, the important thing here is that we are going to then lead. Uh, yeah, so from here, we can then find the distance of A from C. Now, the distance from A from C, which is exactly AC. Okay, so we do that by using Pythagoras theorem. And using that, you see, so you really have a right angle triangle, making things way easier for us. Okay, so in a way, this is how it looks. You see your A, which is this, you see your B, which is that, and you see your C, which is that, and we have what angle theta there. So yes, so we go ahead and then we go on ahead and use the Pythagoras theorem. Continuation of the solution. So here, from the diagram, triangle ABC is the right angle triangle, as we said earlier on. So we use Pythagoras theorem, and this is what we have. And so yeah, so this is just a calculator work. So you just punch all these things and gives you that, and then we find the square root of the answer, and that gives us 320 kilometers, and that's the distance of A from C, which is the same as AC. Okay. Yes, so from there, we then go on to talk about the angle. Now, it's important for us. Now, we already know, okay, this is a right angle triangle. So for us to find your theta, remember, we weren't given what? The hypotenuse. We're only given the adjacent and opposite angles. Yes, opposite side. So we can use tan, which is a trig ratio, so got 12, which is a 12 meaning opposite of adjacent. So we use that to find our theta, and that's what we've done there, okay? And that's what this is just a calculator work. So you have tan theta being equal to that, and then what? Find the tan inverse of it, and then we have your theta to be 39 degrees. Now, it's important for us to look at the diagram. For the diagram here, okay, we found our theta, okay, to be 39 degrees. So if this is 39 degrees and we are to measure it from the north, okay, clockwise, okay, from there north or up to this side. Clockwise means that what? Just as the way the clock moves, okay, the direction of the clock. And here we have to accumulate it. Accumulating means that we add them, okay. If the first quadrant is 90 and this is the second quadrant is 180, so from 180 we then add 180 to 45 degrees and then add it to theta. Here the theta is 39 degrees, so we just add them to it, and then what do we get here? So we do the same thing, we do that, and then we get 264 degrees. That 264 degrees becomes the bearing of A from C. And this brings us to the end of today's class. And please, thank you for taking your time to listen and watch and learn. Please subscribe and like and share. Bye for now.